Welcome back to another video. In this video, we're going to talk about how do you solve exponential equations. Okay, I'm going to show you one way to solve exponential equations, and then I'm going to make another video that shows you a second way how to solve exponential equations. The method I'm going to show you today is going to involve you to rewrite both sides so that they have the same basis. So again, this is just one way for solving an exponential equation. So before we get started, let's talk about what an exponential equation is. So an exponential equation is an equation that has some variable in the exponent. So it might look something like that, a to the x equal b. But as long as the variable is in the exponent and it has an equal sign, it's an exponential equation. Alrighty, so what we want to do in this particular method is we want to rewrite both sides so that it has the same base. So we want it to look something like this: a to the x equal a to the y. If both sides have the same base, then what that means is that the exponents have to be equal in order for this to be a true statement. So if we could get our statement to look like this, this will imply that x is equal to y. So once we get our bases the same, we'll take our exponents, set them equal to each other, and solve for the variable, because remember, our variable is in the exponent. So this is one method for solving exponential equations. So let's look at some examples. I'll show you how to solve some of these. For this first example, we want to solve this equation 4 to the x equal 2. What makes it an exponential equation is the fact that our variable that we want to solve for is in the exponent. So with the method that I'm showing you in this video, we want to rewrite both sides so that they have the same base. So this side, even though it doesn't have an exponent on it, you can't see one, the base will be considered 2 here. And so the question is, can we rewrite 4 so that it has a base of 2? So think about 2. 2 to the first is equal to 2. 2 to the second is equal to 4. So we can rewrite 4 so that it has a base of 2 by rewriting it as 2 squared. And so we have 2 squared to the x. Now you have to think about your properties of exponents. When you have an exponent that's raised to another exponent, how do you combine those exponents? Hopefully you said multiply, because that is definitely how you will combine those. You will multiply those two exponents together. So 2 times x will be 2 to the x. Now again, 2 doesn't have an exponent written on it, but there is an understood exponent of 1 there. And the reason I wanted to put an exponent there, because remember, I just previously showed you that if we could get both sides to have the same base, then the exponents will have to be equal in order for that to be a true statement. So we could just disregard, they don't cancel, you just disregard the exponents and set, or not the exponents, but the bases, and set the exponents equal to each other. So 2x equal to 1, and now solve for x. So I will solve for x by dividing 2 by both sides, and I will get x is equal to 1/2. So x is equal to 1/2, that would be your answer. So that's how you will solve that exponential equation. Let's look at another one. Okay, here's another exponential equation. How do I know it's exponential? Because the variable is in the exponent. So 2 to the 3 minus 2x equal 8. So what we want to do, because of the method that I'm showing you, and this is always, whenever you say exponential equation, this is always the first method you should try to use. Well, you don't have to, but it's a lot easier than the other method that you'll learn in another video. So 2 has an exponent of 3 minus 2x. 2 cannot be broken down anymore. Remember, 2 is a prime number. So the question is, can we rewrite 8 so that it has a base of 2? So remember, 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. So yes, I can rewrite 8 so that it has a base of 2. I could rewrite 8 as 2 to the third. And so I've reached my goal of making both sides have the same base. So since the bases are the same, I don't cancel the bases out. I just disregard the bases, and I take the exponents and set them equal to each other, because the exponents have to equal in order for this to be a true statement. So now I'm going to solve this linear equation by subtracting 3 from both sides, because the goal is to get x on the side by itself. 3 minus 3 is 0. And that 3 minus 3 is 0, leaving me with negative 2x equals 0. Then I'm going to get rid of the negative 2 by dividing both sides by negative 2. And 0 divided by negative 2 is 0. So x would have to be 0 in order for this to be a true statement. And you can check it. If you plug in 0 for x, you get 2 times 0, which is 0. 3 minus 0 is 3. 2 to the third is 8. 8 is equal to 8. So you can also go back, plug it in, and check it. Let's do one more example. Okay, in this last example, we're going to work. It's another exponential equation. We have exponents in the variable, or variables in the exponents. I said that backwards. And if you look, now we have two different exponents with variables, but it's the same variable, so we can solve for it. 27 and 9, neither one of those are prime, but we want to see if we can rewrite both of those so that they have the same base. I usually start with the smallest number and see if I can write the bigger number with the base of the smallest. But 9 to the second power is 81. So I wouldn't be able to rewrite 27 with the base of 9. So is there a number that's smaller than 9 that I can rewrite both sides so that it has that base? And so when I think about 9, the first thing that comes to my mind is 3 squared. 9 is 3 squared. Well, what is 3 to the third? Well, that's 3 times 3, which is 9, times another 3, which is 27. So this lets me know I could rewrite both of these numbers so that they have a base of 3. 27 is 3 to the third, and 9 is 3 squared. So before I can set the exponents equal to each other, I need to combine these two exponents, and I have an exponent raised to another exponent. So if you use your properties of exponents, you will multiply those exponents. That's the power product, the power rule. So this will become 3 to the 3 times 4x, and this will become 3 to the 2 times x plus 1. You can multiply now, or you can set them equal to each other. It doesn't matter what order you go in. I'm just going to rewrite this as 3 to the 12x, because 3 times 4x is 12x, and 3 to the 2x plus 2. How did I get 2x plus 2? I distributed the 2. So that's 2x plus 2. Now they have the same base, and I can set the exponents equal to each other. 12x equal to 2x plus 2. I want to solve for x, so I'm going to subtract 2x from both sides. I get 10x is equal to 2. I have to get x by itself, so I'm going to get rid of the 10 by dividing by 10. So I get x is equal to 2 over 10, which can be reduced. 2 going to both of those numbers. 2 divided by 2 is 1. 2 divided by 10 is 5. So my answer will be x is equal to 1/5, 1 over 5. So this is one way for solving exponential equations, rewriting both sides so that they have the same base. Sometimes you have to only rewrite one side of the equation. Sometimes, like in this example, you have to rewrite both sides of the equation so that they have the same base. If you have any questions about anything I've done in this video, anything I did, feel free to put them in the comments below. If not, I will see you in the next video. Thanks for tuning in.